Hello everyone. In this video, we are going to learn how to solve simultaneous equations using the substitution method. We will start from the main idea behind the method, then we will go through the steps clearly, and after that we will solve several examples together. We will look at examples where one variable is already isolated, examples where we need to isolate a variable ourselves, examples with fractions, and also two very important special cases, infinitely many solutions and no solution. At the end of the video, we will also recap the three possible outcomes of simultaneous linear equations and what each outcome means graphically. Let's begin. The substitution method means replacing one variable so that one equation has only one variable. First, we choose one equation and isolate one variable, for example, x or y. Then we substitute that expression into the other equation. This is important. When we substitute an expression, we use the other equation, not the same one. Then we solve the new equation. Once we find one value, we substitute that number back into any previous equation to find the missing variable. At that point, we choose the equation that looks easiest. Finally, we check the answer in the original equations. Let's start with example 1. We want to solve these simultaneous equations using substitution. Equation 1 is y is equal to x plus 1. Equation 2 is 2x plus 3y is equal to 13. Here, y is already isolated in equation 1. So equation 1 tells us that y is equal to x plus 1. We use this information to substitute y in the other equation. So in equation 2, instead of y, we write open bracket x plus 1 close bracket. This gives 2x plus 3, open bracket x plus 1 close bracket is equal to 13. We now have one equation with only one variable. Expand the bracket by distributing the 3. This means we multiply 3 by each term inside the bracket. 3 times x is 3x, and 3 times 1 is positive 3. So the equation becomes 2x plus 3x plus 3 is equal to 13. We want to isolate the terms with x on the left-hand side, so we move positive 3 to the right-hand side by subtracting 3 from both sides. The equation becomes 2x plus 3x is equal to 13 minus 3. Now we combine like terms. 2x plus 3x is 5x, and 13 minus 3 is 10. So 5x is equal to 10. Divide both sides by 5. X is equal to 2. We have found x. To find y, we can substitute x is equal to 2 into any previous equation. The easiest one is equation 1 because y is already isolated. Y is equal to x plus 1. So y is equal to 2 plus 1. Y is equal to 3. The solution is x is equal to 2 and y is equal to 3. As a coordinate point, this is open bracket 2, 3, close bracket. The solution of simultaneous equations is a value of x and a value of y that satisfy both equations at the same time. Graphically, it represents the point of intersection of the two lines. So if our solution is the point 2, 3, this point must lie on both lines. To verify this, we substitute x is equal to 2 and y is equal to 3 into both original equations. In equation 1, 3 is equal to 2 plus 1, so 3 is equal to 3. This verifies the first equation. In equation 2, 2 times 2 plus 3 times 3 is equal to 13. That gives 4 plus 9 is equal to 13. So 13 is equal to 13. This verifies the second equation. Both equations are satisfied, so the solution is correct. Let's move to example 2. Equation 1 is x plus 2y is equal to 7. Equation 2 is 3x minus 2y minus 5 is equal to 0. This time, no variable is already isolated. We will use equation 1 and isolate x because x has coefficient 1. To do this, we move 2y to the right-hand side. X is equal to 7 minus 2y. Since we used equation 1, we now substitute this into equation 2. So x becomes open bracket 7 minus 2y close bracket. And we get 3 open bracket 7 minus 2y close bracket minus 2y minus 5 is equal to 0. Expand the bracket. 21 minus 6y minus 2y minus 5 is equal to 0. We want the terms with y on one side and the constants on the other side. So we move positive 21 and negative 5 to the right-hand side. This gives minus 6y minus 2y is equal to 5 minus 21. At this point, we have negative y terms on the left-hand side. To make the equation easier, we can multiply everything by -1. This simply changes all the signs. Now we combine like terms. 6y plus 2y is 8y, and 21 minus 5 is 16. So 8y is equal to 16. Divide both sides by 8. Y is equal to 2. We have found y. To find x, we can use any previous equation. The rearranged equation is the quickest. X is equal to 7 minus 2y. Substitute y is equal to 2. X is equal to 7 minus 2 times 2. X is equal to 7 minus 4. X is equal to 3. The solution is x is equal to 3 and y is equal to 2. As a coordinate point, open bracket 3, 2, close bracket. Let's check the solution. Equation 1, 3 plus 2 times 2 is equal to 7. 3 plus 4 is equal to 7. 7 is equal to 7, so the first equation is satisfied. Equation 2, 3 times 3 minus 2 times 2 minus 5 is equal to 0. 9 minus 4 minus 5 is equal to 0. 0 is equal to 0. So the second equation is also satisfied. Both equations are satisfied, so the solution is correct. Let's look at example 3. Equation 1 is y is equal to 1/2 x plus 1. Equation 2 is y is equal to minus 1/2 x plus 5. Here, y is already isolated in both equations. So we can replace y in equation 1 with what y is equal to in equation 2. From equation 2, y is equal to minus 1/2 x plus 5. So in equation 1, instead of y, we write minus 1/2 x plus 5. This gives minus 1/2 x plus 5 is equal to 1/2 x plus 1. To remove the fractions, multiply the whole equation by 2. This gives minus x plus 10 is equal to x plus 2. Move the x terms to one side and the constants to the other. 10 minus 2 is equal to x plus x. So 8 is equal to 2x. Rewrite it as 2x is equal to 8. Divide by 2. X is equal to 4. We have found x. To find y, substitute x is equal to 4 into either equation. We will use the first one. Y is equal to 1/2 x plus 1. So y is equal to 1/2 times 4 plus 1. 1/2 times 4 is 2. So y is equal to 2 plus 1. Y is equal to 3. The solution is x is equal to 4 and y is equal to 3. As a coordinate point, open bracket 4, 3, close bracket. Quick check. First equation, 3 is equal to 1/2 times 4 plus 1. 3 is equal to 2 plus 1, so 3 is equal to 3. Second equation, 3 is equal to minus 1/2 times 4 plus 5. 3 is equal to minus 2 plus 5. So 3 is equal to 3. Both equations are satisfied. Let's move to example 4. Equation 1 is 4x plus 3y is equal to minus 1. Equation 2 is 2x minus 5y is equal to minus 7. No variable is isolated, so we choose one equation and isolate one variable. We will use equation 2 and isolate x. From equation 2, we move negative 5y to the right-hand side. This gives 2x is equal to 5y minus 7. Then we divide everything by 2. X is equal to 5y minus 7, all over 2. We isolated x using equation 2, so we now substitute x into the other equation. Equation 1 is 4x plus 3y is equal to minus 1. Since x is equal to the fraction 5y minus 7, all over 2, we replace x with that fraction. So we get 4 times open bracket 5y minus 7, all over 2, close bracket plus 3y is equal to negative 1. Then we multiply 4 by each term in the numerator. 4 times 5y is 20y, and 4 times negative 7 is negative 28. So the equation becomes 20y over 2 minus 28 over 2 plus 3y is equal to negative 1. Now we simplify the fractions. 20y over 2 is 10y. Negative 28 over 2 is negative 14. So 10y minus 14 plus 3y is equal to negative 1. We move negative 14 to the right-hand side and combine like terms. This gives 13y is equal to 13. Divide both sides by 13. Y is equal to 1. To find x, we can use any of the original equations. The rearranged equation is simpler, therefore we will use that one. X is equal to 5y minus 7 all over 2. Substitute y is equal to 1. X is equal to 5 times 1 minus 7 all over 2. X is equal to 5 minus 7 all over 2. So negative 2 over 2, which is equal to negative 1. Therefore, x is equal to negative 1. The solution is x is equal to minus 1 and y is equal to 1. As a coordinate point, open bracket minus 1, 1, close bracket. Now we check the solution in the original equations. Equation 1, 4 times negative 1 plus 3 times 1 is equal to negative 1. Negative 4 plus 3 is equal to negative 1. Negative 1 is equal to negative 1. So the first equation is satisfied. Equation 2, 2 times negative 1 minus 5 times 1 is equal to negative 7. Negative 2 minus 5 is equal to negative 7. Negative 7 is equal to negative 7. So the second equation is also satisfied. Both equations are satisfied, so the solution is correct. Example 5 is a special case. Equation 1 is 2x plus 3y is equal to 1. Equation 2 is 4x plus 6y is equal to 2. We use equation 1 and isolate x. Move 3y to the right-hand side. 2x is equal to 1 minus 3y. Divide by 2. X is equal to 1 minus 3y all over 2. We isolated x from equation 1, so we substitute x into equation 2. Since x is equal to 1 minus 3y all over 2, we replace x with that fraction. So we get 4 times open bracket 1 minus 3y all over 2, close bracket plus 6y is equal to 2. Now we multiply 4 by each term in the numerator. The equation becomes 4 minus 12y all over 2 plus 6y is equal to 2. Now we simplify the fraction and we get 2 minus 6y plus 6y is equal to 2. The y terms cancel out. We are left with 2 is equal to 2. This is an identity. It is always true. That means the two equations represent the same line. So the lines are coincident and the system has infinitely many solutions. Example 6 is another special case. Equation 1 is 5x plus 4y is equal to 0. Equation 2 is 15x plus 12y is equal to 30. We use equation 1 and isolate y. Move 5x to the right-hand side. 4y is equal to negative 5x. Divide by 4, y is equal to negative 5 over 4x. We isolated y from equation 1, so we substitute y into equation 2. Since y is equal to negative 5 over 4x, we replace y with that fraction. So we get 15x plus 12, open bracket negative 5 over 4x, close bracket is equal to 30. Now we simplify. 12 divided by 4 is 3. 3 times negative 5x is negative 15x. So the equation becomes 15x minus 15x is equal to 30. The x terms cancel out. We are left with 0 is equal to 30. This is a false statement. 0 is not equal to 30. That means there is no pair of values for x and y that satisfies both equations. So the system has no solution. Graphically, the two lines are parallel. They never meet. Now it's your turn. Pause the video and try this system using substitution. Remember the method. Choose one equation, isolate one variable, and substitute it into the other equation. Then press play to check the solution. Let's solve it together. We use equation 1 and isolate y. Move 3x to the right-hand side. Y is equal to 11 minus 3x. We used equation 1, so we substitute y into equation 2. Since y is equal to 11 minus 3x, we replace y with 11 minus 3x. So we get 2x is equal to 11 minus 3x plus 4. Move negative 3x to the left-hand side. 2x plus 3x is equal to 11 plus 4. Now combine like terms, so 5x is equal to 15. Divide by 5, x is equal to 3. Use the rearranged equation to find y. Y is equal to 11 minus 3x. Substitute x is equal to 3, y is equal to 11 minus 9. So, y is equal to 2. The solution is x is equal to 3, and y is equal to 2. You can check your answer by substituting x is equal to 3, and y is equal to 2 into both original equations. Let's finish with a quick recap. When solving simultaneous linear equations, there are three possible outcomes. One solution, we find x equal to a number and y equal to a number. Graphically, the lines intersect. Infinitely many solutions. We get an identity, such as 0 is equal to 0 or another statement that is always true. Graphically, the lines are coincident. No solution. We get a false statement, such as 0 is equal to 1. Graphically, the lines are parallel. If you found this video helpful, please give it a thumbs up and consider subscribing. Thank you for watching, and I'll see you in the next one.